It's Flashcard Fridays at Math Science History, where we explore the beautiful, messy, brilliant evolution of human thought. I'm Gabrielle Birchak, and today I'm briefly covering the life of a man whose mind helped save millions of lives and lay the groundwork for the digital age we live in. He cracked codes, he challenged the norms, he made machines think. He was the one and only Alan Turing. I was inspired by his story while researching the whole story behind Bletchley Park and my interview with Daniel Shiu, which I hope that you check out. Be sure to listen to that interview. It is absolutely fascinating. Alan Turing's story isn't just about victory over Nazi ciphers. This story is also about math, logic, love, betrayal, and the incredible power of human imagination. But first, a quick word from my advertisers. Grab your tea, or in my case, your coffee, your slide rule, and your curiosity. Let's get into it. Alan Matheson Turing was born on June 23, 1912, in Maida Vale, London. His father worked in the Indian civil service, so Alan and his older brother spent much of their childhood in England, raised by a retired army couple. Turing's early academic performance was a bit uneven. He showed a deep curiosity for numbers and patterns, but school demanded classics like Latin and rote discipline. Fortunately, math would wait for him. By the time he was 16, he discovered the work of Albert Einstein. He read Einstein's theory of relativity not only independently, but understanding it without formal instruction. It wasn't that he was a genius in the gifted child sense. He was a different kind of thinker, someone who saw the invisible scaffolding behind systems. In 1931, Turing entered King's College, Cambridge, where he studied mathematics and developed a close emotional bond with a fellow student, Christopher Morcom. Morcom's sudden death devastated Alan Turing, but it also catalyzed his lifelong pursuit of understanding the nature of consciousness, mind, and machine. In 1936, Turing published a paper called On Computable Numbers with an application to the Einstein's problem. That's a mouthful, but it's arguably one of the most important papers of the 20th century. At its core, the paper tackled a question posed by mathematician David Hilbert. Can every mathematical statement be proven true or false by an algorithm? Turing's answer, grounded in logic, was no. And to show that, he invented a thought experiment now known as the Turing Machine. So what is a Turing Machine? Well, imagine an infinitely long strip of tape. This tape is divided into cells. A machine can read, write, and move left or right on this tape, following a set of rules. Despite its simplicity, this theoretical machine could perform any computation that a modern computer can, given enough time and tape. Turing had defined the boundaries of what could be computed and what could never be. This is the foundation of computer science, and he did it before computers even existed. When World War II broke out in 1939, Turing joined the top-secret government code and cipher school at Bletchley Park. It was there that he would help defeat Nazi Germany, not with bullets or bombs, but with logic and machines. The Germans were using an encryption device called the Enigma machine. Its settings changed daily, making it nearly impossible to crack without knowing the initial configuration. The number of possible configurations? About 150 quintillion. Enter Turing. Building on work by Polish cryptographers, he developed an electromechanical machine called the bombe, spelled B-O-M-B-E. The bombe could rapidly eliminate incorrect settings and identify the correct ones by searching for logical inconsistencies in intercepted messages. It was, in essence, the first modern decryption computer. By 1942, thanks to Turing's machines and ideas, the British could routinely read German naval communications. Historians estimate that Turing's work shortened the war by 2 years, saving an estimated 14 million lives. Let that sink in. If you know the history of Turing, and then you realize that he saved that many lives, just let that sink in. After the war, Turing turned his attention back to computing. The war had given him the chance to work with real machines, and now he wanted to build one from scratch. At the University of Manchester, he began designing one of the earliest stored program computers, the Automatic Computing Engine, or ACE. He also wrote the first programming manual. But more importantly, he returned to a question that had haunted him since Morecambe's death. Can machines think? In 1950, he published Computing, Machinery, and Intelligence, which introduced the Turing test. The idea was simple. If a machine can carry on a conversation indistinguishably from a human, then it could be said to be intelligent. The question, whether machines can truly think, still fuels debates in AI today. Turing was decades ahead of his time, not just in hardware, but in the philosophy of consciousness, language, and learning. But the world Turing helped save wasn't kind to him. In 1952, he was arrested for gross indecency because he was gay, a crime in Britain at the time. Faced with prison, he accepted chemical castration through hormone therapy. His security clearance was revoked. He could no longer consult for the government. He was isolated, humiliated, and watched by British intelligence. 2 years later, in 1954, Alan Turing was found dead. He had bitten into an apple laced with cyanide. Some suggest it was suicide. Others argue it could have been accidental. Regardless, he died way too young. He died at the age of 41. The coroner ruled it a suicide. But the greater tragedy is how the state treated one of its greatest minds. But I'm not going to end there. In 2009, British Prime Minister Gordon Brown issued a formal apology. Way too late. In 2013, Queen Elizabeth II granted him a posthumous royal pardon. And in 2009, the Bank of England announced that Alan Turing would be the face of the £50 note, a symbol not just of national pride, but of recognition long overdue. Turing's name is now everywhere in awards, foundations, algorithms, theories. The Turing Award is the Nobel Prize of computing. Tech companies, universities, and even TV shows and films have honored this amazing man. But his legacy isn't just about what he did. It's how he thought. He asked, what does it mean to compute? He asked, what does it mean to think? He asked, can a machine feel, perceive, learn? These are the same questions that drive artificial intelligence research today. Alan Turing was a man of paradoxes. He loved abstraction, yet sought real-world solutions. He helped win a war, yet lost his freedom to the very country he served. He was logical, almost obsessively so, but also deeply emotional. His first love was lost to death. His last years were shadowed by secrecy and shame. Yet, in between, he changed the world. He envisioned a future where machines would not only calculate, but learn, speak, imagine. A future that's now unfolding before us. So next time you ask Siri a question, use an algorithm to find a recipe or encrypt your mail, remember, Alan Turing was there first. Quietly, brilliantly, invisibly. Turing's story reminds us that great minds often live on the margins. That genius can be punished by the systems it serves. But it also reminds us of something hopeful, something deeply mathematical, scientific, and human. That from logic, we can create life and even save lives. From patterns, we can find meaning. And from pain, sometimes we can change the world. Thank you for joining me on this journey through the life and legacy of Alan Turing. If you enjoyed this episode, please be sure to subscribe, share it with somebody who loves science history, and check out the show notes for more resources, references, and bonus content, as well as a link to my interview with Daniel Shiu. Thank you for joining me at Math Science History, and until next time, Carpe Diem.